Okay, this video is about Charles' law. Okay, and Charles' law says that pressure, or volume and temperature have a direct relationship. Okay, so as you increase your temperature, your volume should increase, and the opposite. This is assuming that we have a constant pressure and constant amount of moles. We'll get into different laws where we can start changing those other things, but for right now, you're just focusing on pressure being the same, so you're just looking at volume and temperature. Okay, one of the biggest issues that people have when they're doing Charles' law is that they're not changing to Kelvin. They're just staying in degrees Celsius, and that's a problem because of some ratios that we end up having to deal with. Sorry, I wanted to change these numbers for your sake. And I forgot to do that before I started, but I'm too lazy to go back and restart. So, sorry, deal with it. Okay. So, my problem says a balloon has a volume of 8 liters at 23 degrees Celsius. What will its volume be at 43 degrees Celsius? So, hopefully, I mean, if you're in my class, you know that we've been doing this method, but hopefully if you're in the other classes, you're also doing this method. If not, I highly recommend doing the guess method. So I just read my problem. I identified all the stuff that I'm dealing with, and now I need to write down my givens. So my first given was my first volume, and that was 8 liters. Okay? We know that volume is liters. That's why I knew that. Also, it literally told me what my volume was. Okay, and with that volume, we knew that we had a temperature of 23 degrees Celsius. I personally have my students change that to Kelvin right away before they can accidentally forget about it. So remember, the way you convert to Kelvin is by adding the number 273. Okay, and then they also gave me my second temperature over there. They said that it became 43 degrees Celsius. Oops, so sorry. So if I add 273, this should end up equaling 326 Kelvin. I'm just going to double check because I'm freaking out that I actually did this wrong. Yep. Nope, 316. That was silly of me. 316. Okay, and then I'm missing V2, right? They said, what will its volume be? So now I can go ahead and decide that the equation I'm going to use is Charles' law, because I only have V's and T's right here in my G and U. And now I can go ahead and insert these and substitute and solve. So I'm going to say V1 divided by T1 is equal to V2, which is not my unknown, divided by T2, which was 316 Kelvin. Okay, so we have one unknown, which is exactly what we wanted. We have the 3 givens. Now we need to solve for this V2. When I went to school, I learned it as cross multiplication, cross multiply. But last year I had a ton of students talking about a butterfly method, so I guess I'm just going to draw it in the butterfly way for you guys. So if you don't know what I'm talking about, it's okay. So what I'm going to do is I'm going to say, okay, 296 Kelvin times that V2 was equal to the green wing, okay? So this becomes 8.0 liters. Ooh, that's a bad color. Times 316 Kelvin. Okay, so now I'm out of fraction mode. That's the whole point of doing cross multiplication. It's really hard to think about the fractions. So if you can get it back into a straight equation, you have a better chance of getting it right, in my opinion. So now that we have this all flat out, we need to get volume to be alone. And the way you do that is by dividing it by whoever's touching it. So in this case, that's 296 Kelvin. When we do that, that guy cancels out, and we can plug this fraction into the calculator. So what I'm going to do in my calculator, I'm going to say, okay, 8 times 316 oh my gosh. why am I struggling? 2528 divided by 296. And I end up getting 8.5 liters as my final volume. And if I'm really stressed about getting this right, I can go back and look conceptually, okay? So if I increased my temperature, right, I went from 23 degrees Celsius to 43 degrees Celsius, that means I should be increasing my volume. And I went from 8 to 8.5, which is increasing, which means I did good on this problem.